Hey folks, HPE has a pretty broad portfolio of infrastructure platforms suitable for cloud-native data management and cloud-native workloads in general. And just to kind of give you an informative kind of overview of all these different platforms, but I'm still going to kind of try to hone in on a particular area where we're going to focus on because we have so many products and so many solutions, right? So look at it from the perspective that we provide value to Kubernetes through the container storage interface and how these different platforms provide values to Kubernetes. And just to set the context a little bit, I just want to talk a little bit about the storage-centric use cases that we see in our customer base, and kind of go through the different paradigms on how applications are managed and why that matters, right? So if we're starting from the left and going to the right here, it's very popular to use containers today to modernize your application with different lift and transform patterns or lift and shift. But when you're moving your application from a legacy architecture, there's usually some sort of persistence in the corner of that app, right, that needs to be migrated. And we provide all the means and tools to be able to lift and shift your application from a legacy storage platform into Kubernetes in a completely modernized way to run your app. We also see a lot of IT teams modernizing the entire estate of applications, or the application portfolio, I might say, that they're managing within their enterprise, right? And having a single pane of glass to manage security applications and the works, and also provide persistent storage for many of these applications is becoming pretty crucial. We also see a lot of AI and ML and analytics workloads across the enterprise, where the traditional kind of big data workloads have now migrated, and they want to be able to run that on top of Kubernetes and provide data scientists the tools to be able to spin up environments to do analytics and machine learning across a global namespace in data lakes, as we call them, to be able to share data between different tools and paradigms, and also be able to cross that workload across edge to core to cloud as well. And moving to the fourth column there, when we look at providing Kubernetes as a service, and we see many customers and also managed service providers, they want to be able to provide a single pane of glass for their customers to provision Kubernetes clusters to be able to run their workloads on top of Kubernetes in a completely self-serviced and self-managed way. And of course, there needs to be some sort of persistent storage solution embedded in that, because that is the experience that these users usually get when they provision a Kubernetes cluster in the public cloud. We also see a lot of DevOps shops that are adapting their workloads to build, ship, and run their applications on Kubernetes and integrate data directly into their CI/CD pipelines, right? So you might have a production database running in a monolith somewhere, and you want to be able to clone that database, make it available to a container, and make it available to the build job to run tests and do A/B testing, canary testing, with a subset of that data in an efficient clone, right? Because at the end of the day, we want to be able to drive business outcomes by having agile data services to provide these tools for the developers when they need it, and make the right data available when they need it. Across these storage and data fabrics, we can see the Kubernetes kind of like reaches through the edge to the core to the cloud, right? And at the end of the day, what this presentation will be all about is how we can deploy these different use cases using Kubernetes across all these different paradigms. And to paint a more complete picture, I just want to lay out kind of how applications are deployed on Kubernetes and how they are accessing storage, right? So within Kubernetes, there's a concept called persistent volumes, right? And those persistent volumes can be accessed by applications in three different patterns, right? So you have read-write ones, where you have a single pod accessing storage at any given time. And you have read-write many, where many pods across your infrastructure can access the same data at the same time. on the furthest to the right here, we have read-only many, and that's essentially just providing file access, very similar to read-write-many in a read-only kind of fashion, right? And these apps, they are optimized for certain architectures, like shared nothing distributed. If you would deploy Kafka or MySQL or MongoDB, you would normally have a local read-write once volume for each of the replica that you run in that stateful set. For the read-write-many use cases, you can see like use cases where you have Jupyter Hub, that is a workspace for developers to develop content together and collaborate. And wherever your Jupyter Hub instance spins up, the storage needs to be available, right? And that could be anywhere in the Kubernetes cluster. You can do content serving with the Nginx, for instance, or Apache or any other web server, and they need to see the same data to serve the same content, right? And that's also popular if you're doing read-only file serving as well. That could be done with Nginx. So the container storage interface will simply provide a standardized way for Kubernetes to access block storage and file storage and read-only file through the storage and data fabrics, right? And this solves the problem for Kubernetes in a very neat fashion, right? You have a standardized way to access these different storage paradigms, perfect, right? But the reality is that customers, they have legacy applications that are running on bare metal in virtual machines, and they want to be able to either access data that is running on Kubernetes to their legacy applications, or they might have legacy applications that needs to export data into Kubernetes clusters, right? And that is an important factor when you're deciding on what storage platform you want to pick from, right? Do you want one to just do one thing, or do you want to be able to cater to multiple different paradigms? So with that said, let's dive into the platforms here and go all the way from the edge to the core to the cloud in the HPE product portfolio. HPE SimpliVity is a very dense brick with compute and storage in one single server, and you can run multiple of these and scale them to as many as you need to satisfy a certain workload requirement. It's very efficient virtual machine storage with a 20-to-1 storage reduction. It's very popular for edge and robo use cases. And it's a very consumer-friendly, fully integrated experience for a broad range of applications, right? And you can deploy Kubernetes at ease with the standard VMware APIs on HPE SimpliVity. And looking at how HPE SimpliVity provides value to Kubernetes is that they have a HPE SimpliVity CSI plugin that leverages the VMware vSphere cloud provider interface. They've also augmented this CSI plugin to be able to perform snapshots and clones of their VMDK files stored on their NFS data stores that has been integrated into SimpliVity. And that way you can have your data management tools that like Kasten or Commvault or anything like that can leverage these volume snapshot classes and perform volume snapshots of your applications from your user deployed workloads. Looking at HPE NIMBLE STORAGE DHCI, and it basically combines the simplicity of HCI with the flexibility of converged. You can grow storage and compute completely individually. You get a very highly managed VMware experience from the storage appliance itself, and you manage everything through a single pane of glass in vCenter. VMware admins are very comfortable with this paradigm of running virtual machines. And you can also here deploy Kubernetes at ease with these industry standard APIs that vCenter provides. I'm going to talk about Nimble Storage as a storage platform separately, but if you look at running HPE NIMBLE STORAGE DHCI with the vSphere cloud-native storage paradigm, that means that you will be able to consume VMware as an infrastructure provider when you deploy your Kubernetes cluster. And it will leverage the same VMware vSphere cloud provider interface, but will then instead use the vSphere CSI driver to provision vVols or VMDK files from VMFS data stores that are controlled by SPBM-based storage. And we run iSCSI today on Nimble for DHCI. You can also do fiber channel if you're using the array. And one important aspect here is if you want to perform data management, like creating virtual machine snapshots and such, your data management tools needs to be able to go through the vCenter APIs to perform those operations, right? And a good example for that is that Kasten, they have their own way of communicating. They have the ability to communicate with vCenter as a infrastructure provider and then provide the necessary data management capabilities. Our next-gen all-flash and hybrid storage arrays, such as HPE Primera and HPE NIMBLE Storage, they provide an AI-driven storage experience powered by predictive analytics with an AI engine called HPE InfoSight. Primera is a tier 0 mission-critical platform with a 100% availability guarantee. Nimble is a tier 1 general-purpose disk array. And they both provide block storage optimized for transactional style enterprise workloads. You can get high-end all-flash arrays or low-end hybrid capacity optimized storage with market-leading storage reduction and efficiency. Looking at the value that we provide to Kubernetes with these platforms is that we have a unified CSI driver called the HPE CSI driver for Kubernetes. We have something called a generic container storage provider for each platform, one for Nimble and one for Primera, and also for our future platforms that supports block storage in this paradigm. We have best-in-class data management capabilities that goes natively into the CSI driver itself to perform volume snapshots and provision storage and so forth. And this solution has been validated and certified both with Kasten and Commvault. We also have a dedicated plugin for VSPHERE with Nimble, but we're going all in with the CSI integration with VSPHERE. HPE XP storage arrays is a resilient mission-critical storage for scalable tier 0 workloads. It's an OEM product with a 100% availability guarantee similar to Primera. It's available in all-flash and hybrid configuration with storage reduction and efficiency and such. And it's sort of ideal for workloads that require a proven 8 nines availability. And 8 nines, for you who don't know what that is, that means that you can only have 316 milliseconds of downtime per year. The HPE XP storage team recently released a storage plugin for containers that will give you the option to deploy the CSI driver directly onto Kubernetes, and in turn you will get iSCSI and fiber channel access to HPE XP array. And the data management capabilities are in tech review today, but you will be able to leverage these in a future release and to be able to perform volume snapshots and perform cloning and so forth. The HPE EZMERAL data fabric is optimized for big data, AI, and machine learning workloads. It provides you with a scalable and elastic file and data services fabric that goes across edge to core to cloud, right? And it's also the foundation in the HPE EZMERAL container platform software suite, right? So you can run legacy stateful applications and cloud-native applications on a single fabric. Looking at the capabilities that the EZMERAL data fabric provides to Kubernetes is that you can run both block and file out of the same fabric. And it has a full suite of data management capabilities, such as volume snapshots, and you can provide persistent volume claims to any style of application, right? If it would require read-write once or read-write many, or read-only many, it doesn't really matter. You can pick your poison, block storage, or file storage. And of course, this couldn't be an HPE presentation without some HPE servers. We see that it's a very popular pattern to deploy Kubernetes on bare metal servers and consume local storage, very similar to how you would actually deploy the EZMERAL data fabric. And we have several HPE reference architecture for software-defined storage, such as Red Hat OpenShift container storage. And the cool thing is that you can go composable with Synergy. You can go pizza box style with PROLIANT, or high density for high-performance compute workloads using the Apollo platform. The way we see customers deploy storage-optimized servers with Kubernetes is typically that you statically provision local disk media from either of these server platforms, or you might attach an external disk array such as the MSA to basically provide either file systems or block storage to container-attached storage or software-defined storage. And that could be OpenEBS, it could be Rook, Longhorn, or simply using the local provisioner, right? And those systems in turn have their own CSI drivers to provide data management capabilities to Kubernetes while consuming all but nothing but local storage. So, thanks for watching. My name is Michael Mattsson, that's 2T and 2S, and you can reach me at michael.mattsson@hpe.com or follow me on Twitter at DataMattsson. Until next time, take care.